Okay, today we're going to look at rational numbers versus irrational numbers. Now, it's really simple, really easy. All you have to do is learn a definition. So if you learn a definition, you've got it. All right, so what is a rational number? It's any number that can be expressed as the quotient of two numbers. Or if you like a more simple definition, any number that can be expressed as a fraction as long as the denominator is not zero. So let's take a look at it. Here are some examples of some rational numbers. First of all, every fraction, like 3/4, that's a rational number. How about -7/8? Still a rational number because it can be expressed as a fraction. Now let's talk about integers, like the number 5. Can that be expressed as a fraction? You better believe it. All you have to do is put it over 1. So what if we had -6? Can that be expressed as a fraction? Sure, put it over 1, and it's still -6. Now, the next two things are pretty easy, but are very important. Terminating decimals are rational numbers. What's terminating mean? Well, let's have like 0.8. That's 8/10, which you could write as 8 over 10. And that fraction ends. It doesn't go on forever and ever. You could have 0.1639 and it ends right there. It doesn't go any further. You don't see any little dot, dot, dot or anything like that. Well, that is another example of a terminating decimal. Terminating decimals are rational numbers. If you get a repeater, like 0.3 repeating, in one of our other videos, we'll show you how to change that to a fraction, but you should recognize that as the fraction 1/3. It's a rational number because you can make it into a fraction. So fractions, integers, terminating decimals, and repeating decimals, all of those are examples of rational numbers. So you just have to kind of memorize those. But it might be easier to say, hey, what in the world is not a rational number? In other words, what are some examples of irrational numbers? Well, they are decimals that do not terminate or repeat. So they don't end and they never repeat. You might know a really famous one of those, the number pi. If you've ever tried to memorize the digits of pi, they go on forever and ever and ever and ever. It starts out 3.14159. And I bet there's people in our class that can keep saying more and more digits of it. But it never, ever ends. And it never, ever repeats. So if you're looking for an irrational number, they do not end, they do not repeat. It has to be both of these. If it does both of these things, it is irrational. Do not end, do not repeat. So if you had the number 3.01011 0111 0111, and then they put some dots after it to show that that goes on and on. Well, look at this pattern. Does that ever repeat? No. There's a pattern, but it doesn't repeat. And it doesn't end. So if it never repeats and never ends, it's irrational. Now, let's talk about something called a square root. If we have the square root of 2 versus the square root of 4, most people can tell me that the square root of 4 is 2. So that one will be rational because it comes out a whole number. But we have a whole lesson on estimating the square root of 2. It starts out 1.41 something something something, and it goes on forever and ever. It never ends and never repeats. It is irrational. Okay, so square roots that work out, they're rational. They come out a whole number, they're rational. Square roots that don't come out a whole number, they end up being some kind of decimal that goes on forever and ever and never ends and never repeats, they're irrational. So take a few minutes, study the definitions. It's not really that hard to do.